Welcome back, parents and students, to our next math video. We're going to be working on our math objective that is skip counting, and the objective says we can skip count by 2s, 5s, 10s, and 100s all the way up to 1,000. Now, some of the big ideas that we're going to be working on in this math lesson is that skip counting is simply when a number is increased by the same value each time, going up by the same amount over and over again. Okay, when we are skip counting by 2s, it's every other number. When we count by 5s, once again, it's every 5th number. When we're counting by 10s, we're counting every 10th number, and when we're counting by hundreds, we're counting every 100th number. The point is that we are skipping a certain amount of numbers every single time. So, when we are skip counting by 2s, once again, we're counting by every other number. When I show you a number line, I would expect a student to know that in order to count by 2s, we count every other number. So it could be 1, 3, 5, 7, 9, or 2, 4, 6, 8, 10, and so on. Now, we can count things that there are 2s of. Now, we've talked in class about how if you're counting larger groups of things or something that there's 2 of, it might be easier to use 2s instead of 1s. So I show the example of a group of students with their eyes. And if I wanted to count how many eyes they had, I could count it by 1 individually. However, it's much easier to count it by 2s, so I know that there's 2, 4, 6, 8, 10, 12, 14 eyes. That was much quicker for me to count by 2s rather than counting by 1s. When we are counting by 5s, we are counting every 5th number. That means we are skipping the numbers in between. So we look again at a number line that counts by 5s, and it goes 5, 10, 15, 20, etc. Now, I give the students an example of we can count things that are in 5s like fingers or nickels or things like that. So one thing I did as an example, we looked at just one hand, and if I wanted to count how many fingers were up here on my board, it would make sense to count by 5s because each hand had 5 fingers. So we counted 5, 10, 15, 20, 25, 30, 35. So rather than counting 35 individual fingers, we counted them by 5s. Now on to skip counting by 10s. We are once again counting every 10th number. So 10, 20, 30, 40, 50. Going up by 10 each time. When we skip count by 10s, we count things like, once again, we could use fingers, we could use dimes. This is really helpful with money. And so I ask my students to count how many fingers are on both hands together. So I show a set of 2 hands. Those are groups of 10. It's, again, much easier to count groups of 10 than it is one's individual. So by looking and counting by 10s, we find out that on my board, I had 50 individual fingers that I counted by 10s. And finally, 100s. Skip counting by 100s, we are only counting every 100th number. So we start at 100, 200, 300, 400, all the way up to 1,000. And we can count things like pennies in a dollar, centimeters in a meter, things that there are hundreds of. So once again, rather than counting either by 2s or 5s or 10s, it's much easier to count all these pennies down here using groups of 100. So we can count 100, 200, 300, 400, 500. That strategy was much more useful for us to find out how many were in this extremely large group. Now, I can show you some simple patterns like this, and this will kind of give you an introduction of skip counting by 2s and 5s and 10s and 100s. The important part is that your students recognize that the number is going up by 2 every single time, and we can continue the patterns. Now, these are a simpler version of what we are doing in class because this is similar to things we might have learned in first grade with 2s, 5s, and 10s. Now, hundreds are new. But it's also important to know that students are expected to be able to start at any number and go all the way to 1,000. So in order to go all the way up to 1,000 and start at different numbers, I've come up with some tricks or some strategies that your students might be able to use. First is when skip counting by hundreds. It says the 10s and the 1s place will always stay the same. I'll give some examples of these tips and tricks in action in just a moment. When we're skip counting by tens, the ones place will always stay the same. The ones place, whatever number is there when you start, is what number that will always be there when you are skip counting by tens. When we are skip counting by fives, the ones place will have an A-B pattern. Again, we'll show some examples of that in just a moment. And finally, when we're skip counting by twos, the number in the ones place will either have all evens or all odds. All right, so let's go ahead and do this one together. We start with 425, 427, 429. What we need to do is decide what we are skipping by. Since we know some of those tricks that we've learned, we can kind of decide, well, is the number in the hundreds place changing each time? No, it's not. So we know we are not counting by hundreds. Is the number in the tens place changing each time? Once again, no, it is not. So we can tell that we are not counting by tens. Then, remember our strategy for fives, that the number in the ones place will create an A-B pattern? Well, this goes 5, 7, 9. So once again, I do not think it's counting by fives. When we look at the number in the ones place, we can see that it's actually going up by 2 each time. So 5, we skip 426, then we have 427, we skip 428, and we have 429. So it looks like it's going up by 2 each time. And we can see that the number in the ones place has all odd numbers, so it looks like we are counting by twos. Now to show you an example of that, 5 odd, 7 odd, 9 odd. And if we were to continue on this pattern, you would see that all of the numbers in the ones place are all going to be odd if they follow this pattern. Okay, students, if you're at home, you can try to think of the numbers that will come up next. It's counting only every other number. And you should have gotten 431, 433, and 435. Okay, so hopefully you filled in those blanks. Okay, we're going to go through a few of these, and I'm going to explain how I might solve these if I were a student. We have 4 examples up here. Now, let's look at the first one that starts with 346, 356, 366. Well, remembering the strategies we learned earlier, I can look at the number in the ones place. What I'm realizing is that the number in the ones place has stayed the same every single time. What that tells me is that my number is not counting by twos because it is not increasing or changing at all. Then I can look again at that number in the ones place. I know that it is not following an A-B pattern. It's actually 6, and then a 6, and then another 6. So what I do see changing actually is the number in the tens place. 4, 5, and 6. Yet the hundreds place is staying the same. Now my strategy tells me then that if the numbers are staying the same and the only number that is increasing is the number in the tens place, this one must be counting by tens. So if a student wants to, I allow them to create a ones, tens, hundreds chart. Since they see that the number in the ones place is staying the same each time, they could keep that 6. They see that the number in the tens place is increasing by 1 each time, and the number in the hundreds place is staying the same. They now know that the next number in my pattern is going to be 376. Students could continue on with the pattern, and they would find that the missing numbers would be 386 and 396. Moving on to the next one, 221, 223, 225. Well, if we look first in the ones place, we see that the ones place is changing each time. Well, and then looking at the tens place is staying the same, the hundreds place is staying the same, and the ones place is not creating an A-B pattern. So, if it's going from 1 and to 3 to 5, I should be thinking, wow, those are all odd numbers. This must be counting by twos. So, we continue on the pattern, just 2 more. It's 227, 229, and then it's going to regroup, and so this is one instance where that tens place will change to become 231. Moving on to our next example, 105, 110, 115. Okay, once again we look at that hundreds place, it's not changing. We are not counting by hundreds. Our tens place, it's not changing every single time. It does change from 0 to 1, so we are increasing in the tens place, but only on certain ones. Now here's where that strategy of the AB pattern will come into play. As you can see, it starts with a 5, 0, and then it repeats back to a 5. When we are skip counting by fives and our number is increasing, that ones place will always continue that AB pattern. Just 5 more, 120, 125, 130. Checking it, 0, 5, 0. So it follows an AB pattern, 5, 0, 5, 0, 5, 0. I like to use these strategies as kind of checkers, as a way to check your answer to see if you have done it correctly and correctly counted by either 2s, 5s, or 10s. Now, lastly, if you look at our numbers, we have 577, 677, and 777. What students should instantly notice is that the numbers in the ones and the tens place are staying exactly the same every time. This is a good clue that we are counting by hundreds because the number in the hundreds place is actually increasing. So we can continue our pattern. 877. Okay. 977. And then we are going to regroup into the thousands, 1077. I hope that some of these tips and explanations helped you or helped the parents understand how we're solving these in class. If you want to help out your student, go ahead and just pick a number and create a pattern and ask your students to complete the pattern and also to figure out what it's counting by, whether it's 2s, 5s, 10s, or 100. Once again, if you ever have any questions, please feel free to email me or reach out to me, and I would do my best to help you out. We'll see you next time with another video. Bye.